Hello, my name is Craig and I'll be your host for today's SDK webinar on Error Systems, Rapid Analysis with Plugin Architecture. Today's webinar is going to be delivered by Tom Neely, a Senior Software Developer Advisor at AGI, and it will be introduced by Adam Patterson, a Senior Systems Engineer at AGI.
Thanks a lot, Craig. First, I want to just make sure, can everybody hear me out there?
We can hear you, Adam.
All right, very good. If you can go to the next slide then. Just real quickly, we'll go over the agenda. This is what we're going to go over today. We'll talk about our background and our challenges that we all kind of see out in the market today. We'll talk about our technical approach here at AGI for approaching those challenges. We'll show you some examples. And then finally, at the end, we're going to have some questions and do a little wrap up. So if we can get to the next slide, then we'll go ahead and jump into the meat. Once again, like Craig already said, good afternoon, everybody. I'm Adam Patterson. I'm a systems engineer here at AGI. I happen to be a field engineer based locally in Melbourne, Florida. But like all of our engineers, I work with SDK users across the whole country. Many of our customers building advanced aircraft systems rely on a wide range of tools and simulation environments during their development, such as MATLAB or C++. These are powerful tools, but they can result in a series of unconnected outputs that increase cycle time and mean more issues to fix downstream. Now, wouldn't it be great if you could easily import these and other externally developed models into a common physics-based modeling, simulation, and analysis environment? Well, SDK Aviator is built to do just that, providing that simulation framework with computational capability and a user interface specifically to support aircraft and missile design, mission planning, and extending all of AGI's built-in functionality to capture your customer-developed models. So you can fly your models inside SDK's four-dimensional world, extending those models with Aviator's own powerful capabilities. Tom Neely, who will speak in a moment, is AGI's airplane guy. He flew F-14s for the Navy and then worked at Lockheed Martin before coming to AGI. He also wrote the first SDK radar module, the SDK MATLAB interface, and has built special purpose SDK mashups for many interesting use cases over the years. Tom also created SDK Aviator and has been the lead developer of Aviator for the last 20+ years. So I'm going to say a couple more words about SDK itself, and then I'll turn it over to Tom. So on our purpose slide here, as you may be aware, Systems Toolkit, or STK, is a physics-based modeling environment that allows you to explore the interactions between objects in all domains at once, including air, land, sea, and space. So we like to say that it lets you move your assets through space and time to help you make better decisions faster. SDK includes a wide array of object types with full function GUIs for configuring your simulation and performing analysis. Out of the box, it also allows for integration on many levels, whether that's through files or through APIs, letting you bring in your own data, control SDK externally, or interact with your own models during computation. SDK is built from the ground up to provide a lot of analytical power, but also to be flexible and extensible. Now, the Aviator module takes that basic idea even farther, and that's what you really came to hear Tom talk about. So take it away, Tom.
Thanks, Adam. And welcome, everybody. I see quite a few names I'm familiar with, so thanks for taking some time out to come see the presentation. As Adam mentioned before, and you're probably aware of, SDK gives you this fantastic environment where you can have all sorts of objects moving around. And typically, we give you a lot of models out of the box that you can make use of. But generally, most customers, because of the job they're doing, they want to get their model in. They want to fly their aircraft around inside SDK like their aircraft is supposed to fly. So that's what this presentation is going to be about. It's going to be about getting your aircraft into SDK to do that. And Aviator provides a whole lot of building blocks and raw materials that you can make use of. But we also have a framework that is designed for you to plug things in. And that's actually how I work on a daily basis. And we're going to talk about that. So as I mentioned, it's Aviator is built on what we call the Flight API, and this is a interface framework where objects plug in, and we've got a whole bunch of interfaces that define the relationships between objects, but those interfaces don't say how those objects do their job. You know, over the years, we've built a whole lot of objects, and we've built them in a modular way. So we've got all this computational and user interface functionality that we've designed over the years to model aircraft, and that raw material is available to you. Now, because of the way the API is built, what you actually see in SDK, the Aviator aspect of this, or the Aviator product, that's just one incarnation of what the basic framework allows you to do with all the building blocks. So it's important to realize that not only can you do with the API what you see with Aviator, you have the raw materials to build other kinds of applications that aren't like SDK at all. You could build servers that are used within command and control systems that do divert planning or other kinds of things like that. You can take our building blocks and you can put MEX file wrappers around those things so they would operate within the MATLAB environment. All sorts of things that you can do. So you know, I mentioned that we have this framework. We have this very fine-grained interface-based system. We call it an interface-based design, where we use COM objects that implement those interfaces. And so, you know, we've got this plugin system where everything is a plugin, and customers and users are able to build their own objects that implement those interfaces to do what they do. So we have this idea where with Aviator, everything is a plugin, and you plug it in and it just works. So this is a way where a customer can take their code and their objects and have them run inside SDK as if they're built in. They will look like they're built in. They can have graphical user interfaces. They have functionality. They show up in the GUIs as if they're built in. They act like they're built in. So you can build your objects and have them move around inside SDK. You can put sensors and comms and radars on those things and do all of what SDK enables you to do, only with your exact aircraft. And so some of the raw materials that we provide for you, just out of the box, and we just ran these numbers the other day. Right now we have almost 1,000 interfaces that make up this the relationships between the objects. You don't use all those interfaces, but I mean you could. But in general, there's 50, maybe 100 core interfaces that get used over and over and over again. But there's other interfaces that come along. And then on top of those interfaces, we've built almost 800 different classes, and that encompasses not only computational or low-level or like framework types of functionality, but we also have a whole bunch of user interface stuff that enables you to build the exact same kinds of user interfaces that we build here at AGI. And one of the neat things about getting up and running, up to this point, it might sound like, oh boy, this is computer code. I got to do a whole lot of work to get up and running with this thing. But in reality, that's not true. You can get up and running with Aviator using your own data in a matter of minutes by just bringing in your aerodynamics and your power plant files. We've got plug-in points all over and within our existing systems that can read these external files, and that's how we frequently work with various programs out there. We go to the companies and we get their aerodynamic files, we get their drag polars, we get their power plant decks. When we go talk to the engineers, they know exactly the kind of data that we're looking for. We bring that data into SDK, and now the aircraft is flying around like that static data says it should. We've had really good luck with that. That's an immediate up and running with your data kind of thing. But we also have the ability to do, if you have models, or if your aircraft is let's let's just say, not easily represented by a static file that represents its aerodynamics or its power plant. It's got operating modes. Maybe there's some kind of special things that you guys have put together to let's just say variable geometry. I'll go back to the F-14. Variable geometry. There's all sorts of things that something special about the way your aircraft operates that a static representation doesn't necessarily work that well for. Well, because of the way our system works, you can basically, instead of importing a flat file, you can take your code and you can put a wrapper around it. And if your code is modular in terms of aerodynamics or power plant or the way that it climbs, cruises, descends, takeoffs, lands, etc., you can put wrappers around your code, and then if you follow the rules, the code will just plug right into our existing framework. And the levels of this framework we provide it sort of goes from the point where you don't have to do much to where you can do an awful lot. You can swap out an entire aircraft object if you want to, have that thing show up in our catalog, but that would be taking your entire code base, if you will, for say your mission critical simulations and stuff like that, putting the wrapper around that thing. You build a GUI so you can twist your knobs and dials and do that kind of thing, and then next thing you know, you've got your entire aircraft modeled the way you're modeling it, only now that object is running inside SDK, taking advantage of all the things that SDK can do. You can have multiple versions, multiple instances of your aircraft interacting with satellites and everything else that SDK enables you to do. So that's on the aircraft performance side. We can also go the same description I'm trying to apply on the performance side applies to the guidance, navigation, and control aspects with what we typically call procedures. That's the logic that actually flies the aircraft around to do what it's doing. You can not only make use of our existing building blocks, say you could build one of your own procedures if you want, plug it in and have that procedure make use of our existing building blocks, or you could take your high fidelity guidance, navigation, and control logic that runs inside your 6DOF sim, and you can put the wrappers around that and fly that inside our framework. So this is a way you can sort of evolve with Aviator to get fully up and running from the beginning, up and running immediately, and eventually after you grow into the application, you've got your whole capability as you've designed it, but now it's got this beautiful SDK interface wrapped around it to do all the things that SDK enables you to do. We also have some rather extensive MATLAB functionalities. I know MATLAB is really popular. When I worked at Lockheed, I loved to use MATLAB. And we've got our MATLAB interface to the point where you can actually take Simulink block models. You can strip off the parts of that model that pertains to the actual integration. You can basically make a force model out of your Simulink model. You can run that inside SDK now. And I mean, the caveat to that, and there is a caveat, that we do the integration. Simulink doesn't do the integration. But there's all sorts of neat things you can do there. You can have guidance commands. You can fly your missiles around. We've got the ability to define auxiliary integration states, so you can put dynamics on there, all sorts of things you can do. It's really easy to get up and running very quickly with MATLAB. As I mentioned, you can build customized procedures. In Aviator parlance, the procedure is the thing that you create. It's like the takeoff or the landing or the loop or the missile guidance procedure that defines how the aircraft actually moves. And we've got quite a few building blocks. We've got quite a few existing procedure types, but there's a whole system that is there for you to make use of where you can create your own procedures. And you can take our building blocks and wire them together with specialized workflows or specialized user interfaces to do a whole variety of things. And, a bunch of things that you can think of, things like test and evaluation procedures. We're doing a fair amount of that right now, where the procedures get built based on the means to generate your testing that you're using for your test and evaluation process. And we can provide boilerplate examples of that, so your developers can use those boilerplate examples and get up and running. So here's a list of the current procedures that we have in our stable. There's about 24 of them, maybe more than that. Current procedure. Each of these procedures can be assembled into a customized procedure. Any number of these procedures can be cobbled together and provided with their own user interface. And then we have a bunch of guidance and control strategies that operate with the basic maneuver strategy. And again, these things are not that complicated. The control strategies are not that complicated. So you can define your own guidance laws for how things will fly around. So this brings us to the sort of the art of the possible. You know, I call it selective reuse, but basically that's the idea where you can start simple, where you can use our building blocks, and you have a whole series of levels at which you can apply the API. And really, when you get right down to it, the API is code, and you can create your own objects. For instance, if we are going to build an aircraft, you can swap out the individual, say, climb, cruise, or descend performance models that define how your aircraft climb, cruises, or descend. There's full support for adding entirely new types of performance models for things that your airplane might do, say aerial refueling or carrier landings or things of that nature. And then the really neat thing is that you can then make procedures that you have make use of those special capabilities of your aircraft. So you're able to not only define these capabilities, but then you can invoke special rules for how those capabilities build or get used. And you also have the tools. We give you the tools to make the parts that you're plugging in also plugging in. You can add your own framework. You're not limited to our framework. And I call this selective reuse because to me it's I mean, most customers generally don't want to do everything themselves. They want to buy our software because they want to use the bits and pieces that they they want to reuse what we have that they don't want to build. They want to build parts that they are getting paid to build, but they can come out and use our stuff on top of that. And there's a lot of flexibility in doing that. As I mentioned, we can give you source code. We've got, when SDK ships, we've got plug-in tools that come off of the context menus for an aircraft. All of those are written in C#, and if you contact our technical support, we're more than happy to give you the source code behind any of those tools. We can also give you the source code for procedures that we've built in the house. And that's just sort of the start of how you would get started going down these more advanced avenues. And we can structure any kind of support contract that's necessary to help you along the way. Just as a point of reference, we had he was a pretty bright developer who was working in our teeny toolkit area. Pretty bright developer, but he had no exposure at all to the flight API and basically how Aviator worked under the hood. And we took that developer off and we sort of showed him the ground rules and where the code was and how it put together. And literally within a day, he was building his own procedures that embedded our existing procedures with some really interesting workflows in order to satisfy teeny toolkit testing requirements. It was really pretty neat to see that. So, I really want to get the point across that it is very sophisticated software. It has tremendous capabilities, but it's not that hard to get up and running with it. I'm guessing that based on the title, most of you are probably sort of interested in the computer science behind all this. And so up to now, I haven't tried to spend much time on the computer science. I've sort of tried to focus on what you can do and sort of the higher level ideas. But let's start talking about the actual computer science behind here. We've got a variety of functionality that is available to you when you buy Aviator. This stuff just comes along with it, and so you can make use of that. There is, we've basically what we're giving you with the framework is the exact same framework that we work with on a daily basis. So it's not incorrect to think that everything you see inside Aviator is actually eminently doable by you, the customer, to put the same kind of functionality in there. So within the framework and within the API, we have a bunch of stuff. It's a technical term. But let's just start at the top here. We've got catalog data, and if you're familiar with the Aviator catalog, typically we keep things like pre-configured objects in there, and a lot of times that's aircraft and performance models. It's things like waypoints and runways and things of that sort. Usually those are shared objects. So when you bring one of those, when you go to the catalog and you bring one of these objects into your analysis, that's an object that's shared amongst the other objects that are running within the software. So when you bring up the catalog, there's on the pane on the left. I wish I had a picture of it. Sorry that I don't. But everything that's in the catalog is a plugin. So there's a protocol. There's a set of interfaces you implement for data sources and data items. But that's how you get. If you want to put your own catalog data, if you want to put your own aircraft into the catalog, there's a whole API for how you do that. I mentioned aircraft performance models. I believe right now, if you look at the Aviator Pro license along with Aviator, I think we support three. Actually, we support three aircraft performance model representations. There's actually a fourth one that is available to you where we wrap up the what we call FPMs. But what those things are, if you have jumps or if you have PFPS, those frontline military mission planning systems are all built on top of the validated and accredited flight performance databases. And typically, that usually goes by the word of FPM system. What we've done is we actually created an aircraft representation that goes into our catalog, but it wraps those FPMs so that if you have an F-22 FPM, you can bring that into SDK Aviator and you can fly that F-22 around just like the FPM says it should fly around. You could bring your aircraft in, you could put a wrapper around it and have it show up in the catalog in whatever representation you wanted to display for it. As far as how the actual motion of the aircraft fly around, the basic functionality or the basic, well, it's a mission. It's, each aircraft is represented as a mission object, and a mission object is comprised of phases, and within phases there are procedures. We have a bunch of procedures out of the box, but there's a whole interface framework for how missions and phases and procedures all interact with each other. We have interfaces and standard objects that can be extended for dealing with atmosphere and non-standard atmospheres and wind models. We have functionality that's designed to put together a user interface. A lot of the user interfaces you see on the Aviator GUI, things like the airspeed widgets, the cruise airspeed widgets, just those standard little text fields that if you click on the little button, it brings up the units and things like that. And there's all sorts of other little helper objects that you can take those constructs, those widgets, you can put them onto your GUI and use them. Most applications need to be able to save their state via persistence. And then when you start thinking about it, if you want your system to last for a while, you have to start handling backwards and forwards compatibility. Our persistence system has built-in support to handle that backwards compatibility aspect. We also have functionality that's all about the weight and balance of the aircraft. We have real-time advanced propagation capabilities, most of which you don't even see inside SDK, but we have movies and we have demos that can show you these things in operation. You can actually get our missiles flying out on a training range in a virtual training, well, if you want. You'd have real aircraft flying around, but you'd be able to basically to fly missiles around if you need to, for instance, within the framework. We have this idea called the factory pattern, and a factory pattern is how objects get created. And in the case of the factory object, we have factories for performance models and sites and procedures. And if you look at how the new procedure wizard works on the mission, you see that there are plugins for sites and there's plugins for procedures. I'll show you a little picture here in a little bit. But the factories are interesting in that they are used to not only create potentially more complicated and expensive to produce or create objects, but the factories are also used to invoke like rules and logic that enable sensible arrangements of objects. And for instance, it wouldn't make sense to be able to put a takeoff procedure after you've already taken off. And likewise, you shouldn't be allowed to land before you've taken off. So that's a very trivial example, but there's all sorts of possible rules by which you might want to be able to sequence how your procedures are presented to your users. And the factory is the way by which you set up the logic where you can have the sensible, correct choices available to your users to select from in order to have order and discipline within the tool that you're building. For our save load functionality under the hood, we use the iPersist property bag. That's a Microsoft COM interface. And the main reason we do that is we have this XML gadget that enables us to basically persist a complex hierarchy of objects as an XML file. And since all those objects use iPersist property bag, it's pretty straightforward to take care of that. There's a version independent GUID class. If you think about it, if you're going to save an object, you have to save a representation of the type of object it is, so that when it comes time to load it, you have to be able to create that object. And this is where you start running into backwards and forwards compatibility issues, because here at AGI, what we want to do is we want to be able to, every time we have a major release, we're going to renumber all of our GUIDs so that we can maybe add new functionality, or we have our reasons to do that. But what we don't want is someone who's created a scenario in SDK 10, when they come along to SDK 11, we want to be able to create the right object. It's just a new object, but it's got the old representation of the GUID. And the version independent GUID is the way by which you do that. You have, every time you're going to go to create an object, you look for its version independent ID. You use that to create it. You map that to what it really is as far as being registered on your system. That's the object you create, and that's how we manage to evolve our objects as we go in time. As I mentioned, we have all sorts of user interface functionality. Under the hood, Aviator at its most core level is a C++ thing. The framework that's running inside SDK, at least, is a C++ thing. We've got a whole bunch of helper dialog frames and things like that understand how to pop up arbitrary ActiveX composite controls. So that's the format of the GUI that we're going to use. And there's a factory again that basically maps the you give the factory an instance of the object that we want to put up a GUI for it. You create the factory. We use that factory. We hand it an object. Your factory tells us, oh, for this object, you use this you use this GUI. We take that ID, we create it in the frame that you're using to show that GUI, and that's sort of how we do it. We also have a specialized system making use of the factories, and a special wrapper object where we can make use of .NET forms, and that's how we're doing our T&E toolkit procedures. We're using C# to build those procedures, and we go and we build the GUIs in .NET forms, but we use this special factory object that does all the right handshakes, and so we're able to pop up the .NET form right within SDK, and it looks like it's built in. It looks great. We also have these widgets, as I alluded to, for things like airspeeds and drop edits, and they work on .NET forms too. So, using .NET, .NET is great. It's pretty easy to go off and build objects and build them quickly and have them run very nicely, and when you get done with them, everything just looks like it's built right into the product. We also we have quite a few areas where we're supporting what are called connection points, and I haven't actually set it up till now, but from my language you can probably tell that we're a Microsoft COM based application. We are working on a Java, what's the right word? I would call it a Java bridge. Fundamentally under the hood, we use COM, C++. When we build on Linux, we have our own implementation of COM that we use for that. But we know a lot of our customers are really interested in Linux, so we are in the process of building a bridge to Java where you can basically create all your objects in Java. Same idea that I've been talking about as far as the interfaces in the object and the implementations. It's the same idea, only you would use Java instead of Microsoft COM. But with these events and callbacks, it's a connection point. So we have a variety of connection points that enable you to react to user actions within the Mission GUI, in the Catalog Manager, and 3D Edit. For instance, you can right-click on a control point on 3D Edit, have your menu item come up on that right-click context menu, then pop up a tool, and then that tool can do something special with the procedures that you have selected, for instance. We also have some graphics helpers. For those of you who are familiar with SDK primitives, that's a way for external customers to generate graphics within our 3D globe. We've got a little Aviator wrapper around there, which can speed them up significantly because they know how the primitives work under the hood, and they do some buffering as far as dealing with memory allocation. And so you can get dynamic lines that run within the animation cycle, and they run very, very, very fast. We also have Aviator helpers for dealing with the mouse on the 3D globe. So it enables you to capture the mouse and then process mouse events in interesting ways. We have the Time Fuel Ruler plugin that we ship as part of Aviator. Makes use of these things. As I mentioned, it's .NET code. If you call up our tech support, we're more than happy to send you the source code for that. And so I think we're getting towards the end here, but here I'm going to try to explain how a customer would specify or would manage to get their objects running inside of SDK. And the GUI that's in the background there, that's our new procedure GUI. And that's actually the first page of it where you get to choose the site. And so that left pane there is a bunch of plugins. And in fact, anytime you see a list like that in Aviator, it's almost guaranteed that that's a plugin point. And you see that there's that little file, the text file, and that text file is the standard text file that we ship with SDK, and we call it plugins.xml. But right there, we're showing you the plugins for the site factory there, and so you can see the different sites that are being plugged in there, and users can write their own XML files that have their the registration of the types. You can run those as part of the you can create your own files, and SDK knows how to find those files. So in other words, you don't have to edit this file. I guess that's what I'm trying to say. I'm being all messed up about how to say that. You have the means to create your own files. There's a process in place. You put them in certain places on your hard drive. SDK finds them and then processes them, and then it knows how to form the connections within the software for when we're looking for what's possible as far as plugins. We go off and find your categories. We load those objects and present them as if they're built in. And right here, we're showing you just some of the plugins that we offer out of the box. And as I alluded to earlier, you can create your own plugin categories. You can create your own systems that have their plugin points that your users can extend. Well, I guess we're at the end then. And if you've made it this far, I really thank you a lot. We have, are there any questions?
I think I have one for. I think I have one maybe for Adam. We'll get him back in the fray here. And it says here, can you give an example of an extension that has been written using the plugin framework?
Sure, I can give an example of that, and we kind of alluded to it earlier, but one of the customers that I've been working with on the East Coast, I'll just say, has been planning to fly their aircraft in a different way that's not already supported by Aviator. So Aviator has procedures, like Tom explained. That's sort of the basic building blocks to make it fly the way it's going to fly. And there's really dirt simple ones like just flying straight lines and curves. But then there's more complicated ones for holding patterns. There's some built-in ones for circles and for racetracks and for figure eights. But what this customer needs is for their aircraft to be able to fly back and forth along one line, and they do a turnout at the end, which I call a teardrop. That's probably not the right term for it. Tom can correct me there, but it's like a 90-degree turn and then a 270 turn back, and they come back to the exact point they were on. So that procedure was not already built into Aviator, so we were able to write that up as a plugin and insert that into the listing like Tom was showing earlier, so that now that straight line procedure, it shows up just in the list part of SDK. It looks no different from any other procedure that's always been in a part of SDK. And there's a straight version of that, and there's a curved version of that. So those were examples that we've already seen out in the wild, and that we, AGI, will actually be rolling into future versions of SDK potentially. So that's the power of the extensibility and the flexibility right there.
I don't really have anything to add to that. That's spot on.
Okay, we do have one more question that has come in, but I also want to remind everyone that the GoToWebinar panel has the ability to send a question in. So if you see it, all you have to do is expand the questions tab and then type in your question. We'll see it on our screens, and I will ask Tom and Adam. But one other one we have here is, can you tell us what programs have used Aviator successfully?
Sure. We've been involved on, I'm not going to name any contractors or anything. We've been involved on the F-35 program. We've been involved on the Next Gen Jammer program. As far as just Aviator in general, oh my gosh, the list is very long. We basically try not to use customers' names on these kind of questions. There's a whole host of programs that I have to be careful about typically I think in terms of customers. Why don't we do this? Why don't we get the question asker's name and contact information, and we will send them a nice long list of all the programs that are using SDK Aviator.
Okay, sounds good. And I have one more question that did come in, and someone is so excited about Aviator they want to learn how to get trained up on it. Do we have an idea of how they can do that?
So I'll start that one out. You know, we at AGI have a large amount of training that's already available. You can start off by going to www.agi.com/training. That's the main training area for everything AGI. You can do several different flavors, whether that's instructor-led training at one of our locations, or we can sometimes come to you. We also have online training and tutorials. Sometimes, again, that's instructor-led, but other times there's a large number of tutorials and lessons that you can work through yourself, and you can even get your certification that way. Now, that aims more towards getting you trained in SDK itself, trained in how to learn how to use Aviator, can make you pretty expert in the use of Aviator, and doing things like learning to integrate with other programs like MATLAB. We have a lot of materials available for all of those things. But when it comes to getting into the high-powered use of these sorts of frameworks, you know, that's where I'll let Tom talk a little bit more about how we'd really like to have a relationship with you.
Yeah, the framework is the kind of thing, I mean, most of our customers typically aren't interested in going to that kind of depth, but it really is a key to getting the software more widely deployed within certain organizations that are, you know, the ones that are building applications and have the need for high fidelity representations of their own aircraft. And because of that, what we really want to do is we want to have a support contract, or it doesn't necessarily have to be a contract, but we want our support people to be involved in the with what you're doing. There is a little bit of a learning curve to get up and running, and so it's not the kind of thing where we just want to throw a bunch of documentation at the customer and have them sink or swim. We want to make sure that you can swim. So yeah, if you want to go down that path, we're really excited to do that, but we want to sort of help you down that path.
Okay, I don't see any more questions, but if you have something while we do the wrap up, please send it on in.
Well, yeah, I mean, thank you very much for attending today. It's been a real pleasure speaking with you. I hope I made sense. You know, we've been working very hard on putting this this framework together. I'm really happy that you came out to see what you know, what's possible there. There's a lot of things that we can do, and I'm really happy to have you guys. You know, be here. Thank you very much.
Yeah, thank you very much for joining us this afternoon. We really do appreciate it, and we look forward to talking to you more. Oh, hey, look, that's ways we can talk to you more. So there's the SDK training, the agi.com/training. One of the things I mentioned earlier, and then talking to an engineer. You can get info@agi.com. We also have really great customer support. We've got engineers, a whole room full of engineers that answer your questions at support@agi.com. Please feel free to email us on any of those things and ask us any kind of questions. We'd love to hear from you and start a dialogue with you. I'll let Craig talk about future webinars.
Thanks, Adam. Thanks, Tom. Always stay tuned for at agi.com/blogs. That's where we talk about our upcoming webinars, but also at agi.com/training has a very beautiful drop down. Let me bring it over for you so you can see it. agi.com/ whoop, that's not the wrong one. It's the wrong one. Let me try to do this on the fly while I'm doing it. And Tom's Okay, so here's what it looks like, and these are our upcoming training courses, but we also have our webinars listed here as well. So if you're interested, just go to agi.com/training, and you'll be there. You'll have all the resources available for you there. And then our blog, I believe, is under news, blog, right there. And we're always updating those, I think, either twice a week or weekly. So a lot of options to stay in the know. Again, thanks for attending, and hope to see you at an upcoming webinar or future virtual training event. Thanks.